Since we invented calculus in last week's video, I figured we should be able to answer some final exam questions about the topic. So in today's video, we're going to be answering 3 calculus questions to see how well we understood the concepts that we learned last week. Okay? All right, let's dive right into it. Question number 1. Question number 1 says, what can we say of the limit as t goes to a of the function p of t if we know that p prime of a exists? So here we're interested in some time a, and we know that the derivative exists at time a, which means that the object was moving in a continuous and differentiable manner at time a. So now when it comes to finding the limit of the position function as time approaches time a, what is that limit going to be? Limit means to approximate the value of a certain point as close as possible without ever getting to that point. As we get closer and closer to time a, then the position function is going to get closer and closer to p of a, which means that the limit is going to be p of a. And that comes from the fact that the position function is continuous at time a, which means that there's no teleportation that occurs at time a. So because p of t is a continuous function at time a, then that means that as I get closer and closer to time a, I should get closer and closer to p of a, which is the position at time a. And that comes from the fact that p of t has to be a continuous function at time a, because we know that in order for the derivative to exist at a certain point, the position function has to be continuous and differentiable at that point. So the correct answer will be B, it equals p of a. And that's easy. All right, let's go on to question number 2. All right, so question number 2, a little bit more challenging question, but we got this, right? All right, let's answer 2. It says, evaluate the following limit. Take the limit as t approaches 1 from the left of the function t squared minus 1 divided by the absolute value of 1 minus t. So how do we do this one? So remember, limit means to approximate the value of without actually being the value of. So we're going to approach 1 without ever taking the value of 1. We're being asked to approximate the value of 1 from the left. We want to approximate the value of 1 while being less than 1. We can approach 1 from 2 different directions. We can approach 1 coming from 2, or we can approach 1 coming from 0. Here, the negative superscript means to approach 1 from the left, which means we're going to come from 0 and we're going to get as close to 1 as possible. Now, the denominator says the absolute value of 1 minus t. So if we're approaching from the left, that means that t is always going to be less than 1. 1 is going to be bigger than t, which means that's going to be positive, and we don't even need the absolute value. So we can get rid of the absolute value in this question. And now we can factor the top. T squared minus 1, that's a difference of square. That's going to be t plus 1 times t minus 1. So we have t plus 1 times t minus 1 divided by 1 minus t. T minus 1 is equal to negative 1 minus t. So 1 minus t in the numerator and 1 minus t in the denominator, those cancel, and we're left with negative t plus 1. T is going to get as close to 1 as possible, which means t plus 1 is going to approach the value of 2. And we have a negative in front, so that's going to be negative 2. And the correct answer is answer choice B. The limit as we approach 1 from the left is going to be equal to negative 2. All right, so that's easy. Let's go on to question number 3. Okay, question 3 says, evaluate the following limit. The limit as t goes to 0 of the integral from 0 to t of natural log of 1 plus x dx divided by t squared. So up top we have an integral, and on the bottom we have t squared. With a problem like this, the first thing I would think to do is evaluate that integral so it's written as a function. So we need to solve this integral first. Now, what is the integral of the natural log of 1 plus x? The antiderivative of the natural log of 1 plus x is not a standard antiderivative that most of us are going to be familiar with, right? To solve this problem, what you want to do is you want to write out the natural log of 1 plus x as a Taylor series. Now remember, every smooth and continuous function can be written as a polynomial. That's where the concept of a Taylor series comes from. You need to be familiar with what the Taylor series of the natural log of 1 plus x is. There are a few you should know. You should know e to the x, you should know sine of x, cosine of x, and natural log of 1 plus x. The Taylor series of 1 plus x is going to be valid within the neighborhood of x equals negative 1 and x equals positive 1. And 0 is definitely within the region of validity of the Taylor series of natural log of 1 plus x. So we can definitely use the Taylor series to solve this problem here. And you should know that the Taylor series of the natural log of 1 plus x is equal to the sum of n equals 1 to infinity of negative 1 raised to the n plus 1 power times x raised to the n divided by n. And when you expand this series, you get x minus x squared divided by 2 plus x to the 3 divided by 3 minus x to the 4 divided by 4, etc., etc., etc. Okay? And now we can go ahead and integrate these terms one by one. So the x term, integrating that, that's going to be x squared divided by 2. The negative x squared over 2 term is going to be negative x to the 3 divided by 6. The positive x to the 3 divided by 3, that's going to integrate to x to the 4 divided by 12. And the negative x to the 4 divided by 4 is going to integrate to negative x to the 5 divided by 20, plus etc, etc, etc. And this is going to be integrated between the boundaries of 0 to t. All right, and when we plug in our boundaries, we get t squared divided by 2 minus t to the 3 divided by 6 plus t to the 4 divided by 12, right, etc, etc, etc. Okay, now this is perfect because we have gotten rid of the integral, and what we have up top is a polynomial, and what we have on the bottom is a polynomial, and they're both polynomials of t. We can just divide the top by t squared and see what we get. All right, and when we divide by t squared, we get 1/2 minus t over 6 plus t squared over 12 minus t to the 3 over 20 plus etc, etc, etc. And now this is the perfect time to look at the limit and see what happens as t goes to 0. As we set t to 0, all the terms with t goes to 0, and we're just left with 1/2. And that's going to be the limit. The limit is going to be 1/2. And the correct answer is going to be answer choice A, 1/2. So there you have it. Let me know if you have any questions about what we did in today's video. And I know I have a few loyal subscribers who look forward to my videos every week, so I'll try to post more content as often as I can. But for now, I'm not full-time on YouTube, but I'm trying to get there. If you guys can help make this channel grow by liking the videos, commenting on the videos, that really helps the algorithm and helps boost me in the algorithm so that the channel can get more views and get more subscribers, and I'll be able to post more videos more regularly. And that would be good for me and for you. I love doing this. I would like to do this as often as I can, but I do have other obligations because I do have to make a living at the same time. So go ahead, help the channel grow, subscribe to the channel, share it, and let's make this a good year. We're all about education and self-improvement, so definitely support and help us grow. With that said, I'll see you guys in the next one. All right, bye-bye.